Hello, everyone. Good morning, good afternoon, or good evening, whatever time you're listening to this video. My name is Clemente Rodriguez. These are my partners, McKay Russell,
Hello.
Stephen Marino,
Right.
and Zachary Schofield.
Hi.
Before diving into our work, we want to give a little background information behind our project. Along with old age comes psychological and physiological decline, mostly due to the lack of physical and cognitive activities seniors participate in. These declines are detrimental to the well-being of seniors as they can lead to conditions such as dementia, depression, physical impairments, and much more. To better understand how to combat these declines, a group of seniors participated in a study called Golf for Healthy Aging. Initial baseline measurements of their cognitive and physical abilities were gathered, and over the duration of 14 days, the participants went through a variety of golfing related tests. Preliminary results from the study suggest a positive impact on seniors, despite the study only lasting 2 weeks, showing golf as a potential tool to combat physiological and psychological decline.
And in collaboration with the University of Southern California's Division of Biokinesiology and Physical Therapy, we implemented data mining algorithms to help researchers better understand the data they collected from the GHA study. With use of correlation methods and implementing clustering algorithms, we discovered trends which could then be used to further explain and improve studies on senior health.
And so with that data, we wanted to display it in various ways. First off, we made an interface to display the correlation data that we created. This data ranges in values from -1 to +1, and we display the data in lists of correlations above 0 and correlations below 0. However, since these are two long lists of data, we also have created a search function to make the data a little bit more accessible. And upon searching a measurement, users will be presented with measurements and correlation values related to what they searched. This results in a much shorter list of values and allows users to focus on specific pieces of data. We also wanted to have another way to display this correlation data, which brings us to our interactive heat map. In this heat map, we display a lot of correlation data in an organized way that allows for a better understanding of not only individual correlation values, but different groups of correlation values as well. The heat map allows users to zoom into specific values as well as hover over individual cells, which will display details about that specific cell, like the correlation value and what two measurements produce that value. The higher the correlation value is, the darker the cell will appear, and the lower the correlation value is, the lighter the cell will appear.
So, as my group members previously mentioned, we generated new correlated data from the existing figures gathered from the study, and using this new data, we implemented a k-means-inspired algorithm. The goal was to segregate data based on correlation and place them into corresponding clusters. Figures in these generated clusters would all have similar characteristics, which would aid researchers to further understand the impact golf has on seniors. We applied this algorithm to participants from the study to group any individuals that shared similar characteristics, as well as every measurement collected for every individual to uncover as many connections within the data as we possibly could. Also, similar to our interactive heat map, we set out to create a visual representation of our cluster groups to better visualize any findings and our work. Our interactive clustering display uses pre-generated data and allows researchers to view two different cluster categories: cluster groups centered around measurement figures, and cluster groups centered around participants. It allows for visualization for up to 10 clusters for each category, which will be demoed shortly.
Yep, so like Stephen said, we can go ahead and go over to our website and demo. Here, starting with our homepage, we have our correlation data. And as we mentioned, it's organized in two tables, one with positive values and one with negative values. There's a lot of data in there, and so if we scroll back up, we have our search bar, and if we put a measurement name in there like Quad Max Pre, we can go ahead and search that. and it will give us a table with data that corresponds with quad max pre. So we have all of those measurements and their resulting correlation value. And like I said, all of those measurements are correlated with quad max pre to create those correlation values on the right. And so we can go over to our heat map page. Like we said already, there is a lot of data in this for the correlations. And so it can be a little bit slow, but as we hover over individual cells, we can see that it will show a little display telling us the name of the two measurements that go into that specific cell, as well as their resulting correlation value. Like we said, this helps us get a bigger picture of what the data looks like, and we've organized it in a way that should be helpful. We can also go on to our clustering page. And here, like we said already, we have the ability to choose a number between 2 and 10. We can choose something and then submit that, and it will repopulate our table and our display with data from a different file. And so now it's doing, I believe, 8 clusters. And so we can hover over that and see the data. Or if we scroll down, there's tables that provide the same data, but in a list format. This is true for the participant clustering as well down below. We can, again, put in a number and then click submit, and the page will reload, and it will have the requested amount of clusters. And again, if we scroll down, there are the lists of data there. And that concludes our presentation. Thank you.
Thank you.
Thanks.